Hey, what's up guys? My name is Saurav and welcome back to my YouTube channel. So if you are new here, make sure to subscribe to my YouTube channel. So today I'm back with another project that is face mask detection. And according to me, this is really exciting and practical project. And the reason being, you will be seeing a practical application of what you have learned so far. So first, let's define the problem statement or try to understand that what we are trying to achieve here. So let's suppose your client is one of the famous restaurant in your city, and since the COVID is still here and there are restrictions set by the government in public places and restaurants, so they want to develop a system that can detect whether the person has wear mask or not, and they have approached you for this problem. So now your task is to build such a system. So if we take the example of this image, you are supposed to build a model that can detect that, okay, in this image we see three faces and one of them has not wear mask and other two have wear mask. So in case of no mask, there should be a red box around the face. And in case of there is a mask, there has to be a green box around the face. So the next question is what kind of knowledge we should have to be able to build such a system. So here are the things that we are required to know. So first and the obvious one is knowledge of deep learning concepts like ANN, CNN, backpropagation and all that. And the next one is one of the widely used concepts in deep learning. So this is known as transfer learning, where we use the learning of one deep learning model to build our own model. So in this case, we are going to use mobile net architecture. Then we must know TensorFlow or PyTorch. For our case, we are going to go with TensorFlow. I should have listed that one. And if you don't know anything, you can watch my playlist on deep learning with TensorFlow, which is in the I button. Next, we need to know the OpenCV library because using that, we are going to access the camera and run the algorithm in real time. And lastly, we should know what is Haar Cascade and how it works. And why we are using Haar Cascade? We are using it to get the faces in each frame of the video. As of now, this might seem a bit confusing because it is unorganized. We don't know in which sequence we are going to do things. So next we are going to discuss the approach that how we are going to solve this problem. So I have divided this problem into two parts. In the first part, we are going to build a classifier using transfer learning. It will be able to detect whether a person has wear mask or not. In the second part, we are going to run a Haar Cascade classifier. So now let's deep dive into this and try to understand that how our actual program going to work. So first we have the mask data. So let me show you the data. So here we are on Kaggle and thanks to Prithviraj for curating the data for us. Make sure to follow him on Kaggle. And please don't download the data. I'll tell you how to access the data directly from Kaggle to Google Colab. So if you look into the data, you can see that we have face with mask and face with no mask. And notice that the folder structure is something like this. We have train, test and validation, but we are going to use only the training data because that will be sufficient for us. So now let's get back to the PPT. So using that data I showed you, we will be building a classifier first, and then we are going to save that model. So this is the first part of the problem. Now in the second part, we are going to access the webcam, or in our case, we are going to access the camera fitted in the restaurant. And we will be feeding the video coming from that webcam to the Haar Cascade classifier. And after that, it will give us faces in the data. And then we are going to run the model that we have built. So if we take this example, Haar Cascade will give us three faces, and now we are going to run the deep learning model on these faces. And everything will happen in real time, there won't be any delay. So that's what we are going to do. So let's jump to the Google Colab and build our deep learning model. So I have imported all the libraries required for this project, and the link for the dataset and this notebook is given in the description box. So you can copy this piece of code from there. Next, we are going to change the accelerator from CPU to GPU so as to make the training faster. So click on Edit and click on Notebook Settings. And here you can see that in my case, it is already GPU. So make sure this is the case with you also. So next thing we have to do is to connect the Kaggle to the Google Colab, and for that we need API key. So to get the API key, we have to go to the Kaggle. So first we have to go to the Kaggle profile, and then we have to click on the account. Now if we scroll down, we see an option of create an API token. Click on that and it will download the API key in JSON format. Now we have to upload this file. So to upload this file, we have to do file.upload, which gives us this option to upload the file from the local drive. So wherever your file is located, just go there and upload it. In my case, you won't be able to see the window because this is happening due to the limitation of screen recorder. And now here you can see that JSON file is being uploaded. Next, we have to make sure that we are setting up the Kaggle environment in the same directory where we have our JSON file located. So this code is going to make sure that both the things are in the same directory. And if I'm talking about the same directory, I'm talking about Google Colab directory. So next thing we have to do is to download the data from Kaggle to our Colab environment. And we are going to use this command. So where to get this command? So let's go back to the Kaggle. So here we have the data now. So you see the option of new notebook at upper right corner just beside the download option. There you have three dots, click there and you will have the option of copy API command. And sorry for this cropped video. Now we just have to paste that command here and make sure to use sign of exclamation before running the command. So here you can see that data is directly getting downloaded from the Kaggle. So now let's look into the file. So here we have the data set, but the problem is that it is in zip file. So the next thing we have to do is to extract the zip file. And for this, we are going to use the command which is saying unzip everything that has .zip extension. So now here we can see that all the files are getting unzipped. And if you don't want to see this unzipping thing, you just can cross this thing. So now all the files are unzipped, which means that we have a folder structure like we saw in the Kaggle, that is train, validation and test. And next we are just confirming this thing. So we are printing out the folder and the number of images in each folder. And if you want a detailed explanation of this code, you can watch the COVID detection video. So here we can see the folder structure. So we have three main folder and then within that we have no mask folder, which contains different number of images. So if you want to confirm this thing, let's check whether this is true or not. So here we have new folder, that is new mask dataset, and then we have train, test, validation, all the same thing that we have printed out. Next, we created a function that is going to take two things. First, the directory, and the second one is subdirectory. And then it will print out an image randomly from there. And I have already talked about this code in the previous video. And the purpose of this function is to check out images from the folder. One thing you can do is to change this code and ask the user how many images they want to see. As of now, it only returned one image, but you can try to return 10 or 15 images. So now let's check this function. So first we are passing the directory and then we are passing the subdirectory. And here we can see a person with no mask. Similarly, we are going to grab the image from mask data. So let's do that. And here we can see a person with mask. So the next thing we have to do is to read the data. So first we are going to create two empty lists. One will store the image data and one will store the label. Next, using OS list directory method, we are getting the list of all the images present in that particular directory. So in this case, in the non-mask directory, whatever be the file is, their name will be in the list. Next, we are looping over the list, and inside the loop, we are reading the images by passing the absolute path of the folder and then adding the image name. And this will help us to create an absolute path for that particular image. And then we just have to use OpenCV to read the file. Next, we are resizing the image by 224 by 224. And the reason being, before feeding the images to the algorithm, we have to make sure that every image is of the same size. Next, we are appending these two lists that we have created. So first we are appending the images. Then we are appending their labels. So here 0 means there is no mask in face and 1 means there is a mask on the face. Now the same thing we are going to do with the mask data. So we have to just change the file path and then we have to change the label. So here instead of having 0, we have to have 1. Next, we are converting the list of images and labels into NumPy arrays because this is how we have to pass the data into the next step. And also we are scaling the images by dividing it with 255. So why we do this? This is to make sure that the training time is faster, and the reason for dividing it by 255 is that the highest pixel value is 255. So after this transformation, every pixel value is between 0 and 1. Next, we are dividing the data into two parts, training and test. Although we have the test data, and if you want to load that data, just follow the same steps. But here I'm just going to use the training data and going to split that. So we are keeping 80% of the data for the training and 20% of the data for testing. So now the next block is all about transfer learning. So if you don't know what it is, you can watch my playlist on TensorFlow. So basically here tf.keras.application, and if you do dot, then you will have many architectures like VGG16, VGG19, MobileNet, ResNet, Inception, etc. etc. Then we have to pass few things. So first we have to pass the input shape, and it is equivalent to the shape of the image. So that is why we have to pass 224 by 224 into 3. Next we have to pass the weights. So basically which weights we want to use. So we want to use the weights of ImageNet challenge. Next we are setting include top equals to false because the first layer is input layer. So we want that according to our image data. Next, we have the most important thing, and if you don't do this thing, the whole purpose of transfer learning will be defeated. So here we are freezing each layer. So when we say we are freezing the layers, it means that we are freezing the weights of the networks. So for layer in base model dot layers, give us the list of all the layers. Then we are just iterating over them, and then we are setting it equals to false. So this layer dot trainables equals to false is making sure that each layer is getting freezed. Now here I want to talk about one more thing, that is fine tuning of models in case of transfer learning. So sometimes we don't get desired results even with transfer learnings. In that case, we start unfreezing a few layers in the model. And in most of the cases, this helps the model a lot. So if you want to improve the model, you can try doing the same thing. Next, we are flattening the output coming from the mobile net, and then we are adding some dense layer in the model. Here I have only added two dense layers. You can try adding more layers. Next we are creating the prediction layer. Here we have to pass only one neuron, and we have to pass activation as a sigmoid function. And this will help converting the numbers into probabilities. Note that in case of binary classification, the preferred choice is softmax function. In the next line, we are just adding the two parts of the model. So first we have the CNN, that is mobile net, and then we are adding the custom layer that we have built, and then we are clubbing them. And finally, we are compiling the model here by setting the optimizer equals to Adam, then we have loss equals to binary cross entropy, and then matrix equals to accuracy. So that's all we have to do for the model building, and this is how we build a model in transfer learning by using some other weights, and then we are adding just our own layers. So now let's train the model. So here you can see that the training has started, and this may take some time, but given that we have GPU and our data set is not that much big, plus MobileNet is very fast to train, so you won't have to wait that much. But still, let's fast forward in time. So the training has completed, so now let's make the prediction on the test data to see how it's doing with the unseen data. So we just have to call the predict method and pass the data, and it will spit out the probabilities for us. So let me show you these probabilities. So here we can see that we have the probabilities. Now we are going to create confusion metric, but for that we need this thing as 1 or zeros. So in the next block of code we are doing that, but let me first delete it. So here we are running a for loop, and inside the loop we are just saying that if the predicted probability is greater than 0.5 or 50%, then append it as a 1. That is, there is a mask. Else there is no mask, so append it with 0. And with this block of code is going to make sure that we have only 1 or zeros. Next, we are creating a confusion matrix, and we are converting it into a pandas data frame to make it more understandable. So let's run this cell. And here we see that there are 5 images that are misclassified out of 120 images. So we are getting an accuracy of 96% on the test data, which is not a bad thing. But again, if you want to improve the model, you can fine tune it like unfreezing, few layers, and then adding more dense layers, and you can try any other thing that you know. But as of now, we are going to go with this model. Next, we are going to save the model. So first, what I'm going to do is to give the location, and with that, I'm going to pass the model name. So next, we have to call the tf.keras.model.saveModels. Then we have to pass the model and the model name. So now let's run this cell and save the model. So we have saved the model. The next thing we have to do is to download it locally because it is still in the Google Colab environment. So here we have the model. Now click on three dots and now you have the option of download. Now it will take some time to download, and with this we have completed the first part of the problem. So next we have to use the model and Haar Cascade classifier to build the system that we have talked in the slides. And that is something we are going to do in Jupyter Notebook, and the reason being this is not that much computationally expensive because now we are just going to use the model to make prediction, and that is something machine can handle. And make sure that the model, Haar Cascade and the notebooks are in the same folder. So let's jump to the Jupyter Notebook now. So here I am in the Jupyter Notebook, and this part is going to be very similar to the face detection video. So if you have watched that video, most of the part you can skip. And this section is going to be very quick because I have already talked about most of the things. So if you have any doubt, you can watch that face detection video. So first we are importing all the necessary libraries. Next we are loading the classifier, that is Haar Cascade classifier for frontal face detection. And then we are loading our model that we have built on the mask dataset. So next we are going to display some text along with the boxes like mask off or mask on. And we are setting the font style and then font size, which is something we are going to use later. In the next block, we are creating a function that is going to take the image as an input and going to do some transformation to make sure that we are giving the right input to our deep learning model. So once we have the right input, it is going to feed it to the model, and this function is going to return the probability in the end. Next, we have the detector function. So it takes two inputs. First, grayscale image, and the second one is colorful image. Then we are feeding the black and white image to the face classifier because we know that it only works on the black and white images, and it returns four things, that is x, y, width and height of the faces. So in the next block we are running a for loop over all the faces it has detected. Then inside the loop we are cropping out the face, so ROI and then frame, and then we have to do little bit of indexing. So now we have only the faces out of all the things in that image, or you can say frame. Next we are going to call the predict method and pass this ROI color and save the prediction inside a mask variable. So now it has the probability. So next we are running a if and else condition which says that if the mask value is greater than 0.5, or you can say that there is a probability greater than 50%, we are considering that there is a mask on that face, and inside that we are going to draw a box around the face. So cv2.rectangle, then we have to pass the frame, and then we have to pass the upper left coordinates, and then we are passing the lower right coordinates. Then we are deciding which color of the rectangle should be, so in this case it is going to be green. And next we are deciding how thick we want the boundaries of the rectangle. And similarly we are going to show some text on the frame. So for that we have to call cv2.putText, and then we have to pass the frame, and then we have to decide what kind of text we want, or what should be the color of the text, or you can say what is the thickness of the font, all that thing. So it is quite understandable. Now in the elif block we are saying that if the probability is less than equal to 50%, consider there is no mask on the face. So now we want to draw the red color rectangle. That's why we see only color has changed from 02550 to 00255. Similarly, in put text, we have changed the text from mask on to mask off. And finally, this function is going to return the frame. So now this frame will have the rectangle drawn around it based on the prediction made by the model. Now the last part of the problem is to access the camera, then passing the video to the detector function. So first we are going to access the camera using video capture. Then we have to pass 0 if you are using default webcam. And if you are using some external device, you have to pass 1. Next, we are going to run a while loop and we will have a break condition. So this will allow us to keep running the webcam till the time we want. Inside the while loop, we are reading each frame coming from the webcam and it returns two things. First one is not that much important and the second one is the frame itself. Next, we are converting that frame into grayscale image because we know that our Haar Cascade classifier works only on grayscale image. And if you think I'm going too fast or you need a detailed explanation, you can watch my playlist on OpenCV. Next, we are running the detector function. So we have to pass the grayscale image as well as the frame itself. And next, we are assigning it a variable. So this variable will have our frame with box drawn around it. Next, we are showing the frame using IamShow method of OpenCV. Then we have to pass few things. First, we have to pass the frame name and then we have to pass the frame itself, that is the detect variable. Next, we are writing a condition that says that if the user press Q from the keyboard, then break out of loop, which means that it will stop the program. Now, the last thing that we have to make sure is that all the resources that are being used by OpenCV must be released. For example, if it is using camera, like here we have used video cap dot release, it means that as soon as the loops end, it will release the camera. Next, we are also destroying the windows that the function has created. So that's all we have to do for this project. Now it is time to check whether we have done things right or not. So let's run this cell and see how it is doing. So now here you can see that I have mask on. So we are seeing a green box and then we have this mask on written. Now if I remove the mask, you can see that as soon as I do that, this triangle goes red, sorry, and you can see the mask off. So next I'm going to show it a picture of mine from Instagram and see if it is able to do that. And by the way, if you are on Insta, feel free to connect. So now here you can see that it is able to detect if I keep my hand stable. So you can see that it is doing both the thing. It is detecting me and as well as my photo, which is a good thing. So now you can end this program by clicking Q on the keyboard. So that's all from my side. I hope you enjoyed this project. So if you are new to this channel, please do like and subscribe and press the bell icon for the future updates. Till then, bye, stay safe and wear a mask.